All right, folks. Hopefully you can hear me. I've got to do Zoom this time because I need to share Desmos with you. But let's make sure. Okay, so here we are. Let's make sure that our volume is up, and as usual, we want to make sure we are taking everything, all the notes, on the left side and showing the same amount of work on the right side. Okay. So, left side we're going to do together. These are the most missed problems on the test. When we see a function that models the height of an object or a rocket over time, we just want to pop that in Desmos. So notice when we pop it in, it says, what is the best domain for this function? Well, the first thing we need to think about, this is height versus time. Okay, so our domain is time, and I know this because my domain is always the variable that's built into the equation, and this says height is a function of time. So time is my domain, and let's make sure we're taking these notes. Time is the domain. All right, and now I'm going to go ahead and I'm going to pop this in Desmos, and I think you all should try this with me. All right, so here we go. It is h of t equals negative 16t squared plus 500t. Okay, and now we've got to get our picture so that it actually looks like a rocket being launched. I always go, let me move this out of the way to my tool gear. And first thing I'm going to do, you can tell there's way too much X there. So I'm going to bring this down to like 4, and let's take this down to like a -1. Um, actually, we might need a lot more. Hang on, let's see. Yep. Okay. So I needed more than that. So notice my X here is at 31.25 is where it comes back to hit the ground. If we don't really need to, but if we needed to find the top of this, I could go back and make my Y a little bit bigger. Let's see. Wow. Wow. So that's on up there, 1500. So anyway, this is really all we need because domain is on the x-axis and it's time. So notice my time starts at 0 and it's going to go to 31.25 seconds. So what I'm going to do, let's do this. So what I'm going to do is I'm going to draw a picture and I want you to do it as well. Okay. This is 31.25 comma 0. And this is obviously 0, 0. And this is our domain right here. So when we take a look here, also keep in mind, these are expressions for the domain, whereas these h of t's, these are expressions for the y. Okay, so go ahead and put y right there. That's for the range. Okay, so the correct answer is A. Okay, now what you need to do is pause the video and you need to go ahead and put this in Desmos. Let's draw us a model, okay, for the rocket being launched. Fill in your numbers, okay? And then if you're listening, let's go ahead and draw a heart right here next to number 1, okay? All right. Question number 2. We're given a line, and notice it says, what is the slope of all lines that are parallel? So we're going to write two things. First thing we're going to write here is parallel lines. And you're going to write have the same slope and underline the word same. Okay. And then under perpendicular slope, I want you to write opposite reciprocals. Okay. So now let's find the slope. So I'm going to find where this line goes through two good points, right through the corner of these boxes. Here's one as well. So now I'm going to draw me a right triangle. I'm going to rise 1, 2, 3, 4, and up is in positive direction. Then I'm going to run to the right 2. Remember, slope is rise over run. So that's 4 over 2. And that reduces to a 2. So if I want slopes of the parallel lines, then we had written here they're the same slope. So this is the correct answer. Now, it just added a little something extra for you to do. The perpendicular slope, we would flip that. So instead of 2 over 1, it'd be 1 over 2, and we changed the sign. So that's positive, so that would be negative. All right. Now you can pause the video and do the one on the right. And if you're paying attention right over here, I want you to write gobble, gobble. Right? All right, question number 3. Kelly surveys several students asking for the number of hours they spend daily on social media and for their grade point average. She models the data with a linear best fit function, and then it says which correlation coefficient would indicate the strongest relationship. Okay, first of all, we need to remember that correlation coefficient, I'm just going to write short for that. That is the R value that's in the line of best fit. And so in this one, you've just got to go off the numbers that they give you. So remember, strongest, let's go ahead and write this, strongest is closest to a 1 or a -1. And remember, the negative has nothing to do with strength. So if you notice 0.4, 0.2, 0.5, 0.9, 0.9, even though it's negative, is still the strongest. So that's what you should have circled. Okay. Now, we're doing a little extra exercise where we're going to put these in order from weakest to strongest. Okay. So we already know the strongest is -0.9. So we can put that there. Okay, and then we're going to go down. So we've got 0.5, 0.4, and 0.2. Does not matter that it's negative. Negative 0.5 would be next, then 0.4, then 0.2 is the weakest because it is the closest to 0. Okay, so hopefully that helped. All right. Last question. A certain stock has an initial price of $1,000. The graph shows the price of the stock over the next 10 hours. What is the domain of the function? So again, what we have to remember is domain is the x-axis. It's the x value, so we're looking at time. And then notice that the time is going to start at 0. It doesn't matter that this goes back before that because a negative time does not make any sense. So time of 0. And notice it crosses over 10 seconds while the stock prices are positive. And the other thing is it gives you an indicator here of exactly how long the domain goes for. So if you read that part of it, it's telling you that it's from 0 to 10 hours. So real numbers from 0 to 10 hours is the correct answer. All right. If you are paying attention, let's draw us the best turkey we can right here on the bottom. And then I want you to flip over on the back and I want you to write Happy Thanksgiving. I hope you all have a great day.